Polynomials today, and we've kind of been doing this a little bit already. Right before break, we took given a zero or given a factor and used synthetic division to break a polynomial down. We're doing the same thing today or this week. The only difference is we're not giving you a factor or not giving you a zero. We've got to come up with it on our own first. Okay, so we're just starting with a polynomial and figuring it out. Okay, that's what our goal is this week. So zeros and polynomials, there's this thing called the rational zeros theorem, and what it creates for us is a list of possible rational zeros. A rational number, remember, is a number that can be written as a fraction. So when I say a rational zero, I mean a real zero that can be written as a fraction. So that opens up numbers like 1/2, 2/3, -2/3, -1/2. Even integers like 2 or -7, those are rational numbers as well. So the possible rational zeros, we list them as P over Q. And what that means is the factors of the constant term over the factors of the leading coefficient. Okay, factors of the constant term divided by the factors of the leading coefficient. And what it creates is a list of the possible rational zeros. If the polynomial has a rational zero, it'll be in this list. Okay, so one of the skills you're going to learn this week is making that list, and then we're going to utilize that list in order to get a zero. Instead of me handing you one at the end of the problem, you're going to have to use this list to find one. Okay, and I'm going to help you out with that list as far as an easy way. So the first thing we're going to do, we're just going to practice making that list. List the possible rational zeros for said polynomial. So example A, function f of x is equal to x to the third power plus 2x squared minus 11x plus 12. Okay, I'm going to preface all this by saying that you could also, for any of these problems, look at the problem as a whole and think about GCF. If there is one, it can make that list deal with smaller numbers. Okay, so look for a GCF. If there is one, then you could factor that out, and that might make your numbers smaller, so it makes the list easier to make. Okay, smaller numbers usually have less factors, so that makes the list easier to make if there is a GCF. Is there a GCF to this problem? No, obviously not, because you have a 1 in front of x cubed. So your leading coefficient, this is your Q, this is P. Okay, all right, so when we make that list, we're going to list the factors of 12, okay, and we put a plus or minus in front of all of them. I'm just going to put one plus or minus in the front, and I want you to understand that goes to every piece that I put after it. Okay, plus or minus out of that. So what are the factors of 12? What's it mean to be a factor? Of 12. What's that? Oh, it means that it divides into it evenly, or it pairs with another number to multiply to be 12. That's what a factor means. Good job. Way to go. All right, so easiest factor for 12 would be 1, right? 1 goes into 12. So what's the partner that goes with 12 to make 12? 1 times 12 is 12. Okay? Well, I also happen to know that 12 is even. So that means what goes into it? 2. What partner goes with 2? 6. I made it past 4th grade, so I know that 3 also goes into 12. Because 3 times what is 12? Those are my factors of 12. Bless you. Q, we have a 1. What are the factors of 1? 1. That's it. It's nice when that leading coefficient is 1 because there's only one number in the bottom. It means we don't have anything to deal with fractions. All right, so that gets us the factors. Now we have to make that list. That list converts over to taking each of the factors on top and dividing by each of the factors that are on the bottom. Since there's only a 1 down here, we're going to divide 1 by 1, 2 by 1, 3 by 1, 4 by 1, 6 by 1, 12 by 1. If there were another factor, we'll get an example with a different number down there in a minute. But you're dividing whatever's down here into each of these individually, and that creates a list. 1 divided by 1, 1. So it's plus or minus 1. I'm going to put plus or minus and then a little curly brace to say it's plus or minus everything after that. 1. 2 divided by 1 is 2. 3 divided by 1 is 3. 4 divided by 1, 4. 6 divided by 1, 6. 12 divided by 1, 12. What that means is this polynomial, if it has a rational 0, it will be in this list. It'll either be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. It'll be one of those 1, 2, 3, 4, 5, 6, 12 numbers. So we've narrowed down the possible rational zeros from every number in the world to only these 12 are the possible ones that we could do. Okay, so that's what we're doing. We're narrowing down from every number in the world to a smaller list. Sometimes the list is longer than this. Sometimes it's even shorter than this. Depends on the numbers for P and Q. Okay, so that's our list. What we would do then is we would take that list, and what I had to do when I was in high school was try one or all of them and find which ones works. I'm going to show you a better way in just a little bit, okay? Let's work on making that list first. It does. It does. All right, so let's look at this polynomial. G of x is equal to 4x squared. Let's do x to the 4th. We're dealing with higher degree polynomials. We're smart enough to do that. All right, this is a fun one. We have P and Q. P is what for this one? 10, and Q is 4. P over Q. Possible, or what are the factors of 10? 1 and 10, 2 and 5, and that's it. So there's only 4 factors for 10. What are the factors? Yes, ma'am. I'm sorry.
That's okay.
We're out of room on our sheet too. Okay, when is she gonna make it? Okay. All right. Factors of 4. 1 and 4. 2 times 2, right? So here we have 3 numbers in the bottom. Okay, so that means we're going to have to take each of these 4 factors and divide by each one individually. So when I make that list, I'm going to put plus or minus in the front. 1 divided by 1, 1. 2 divided by 1, 2. 5 divided by 1. 10 divided by 1. That takes care of the 1 on the bottom. Now we got to divide by 2. 1 divided by 2, that's 1/2. Thank you very much. And then 2 divided by 2 is what? We've already got that listed, so we don't write it again. 5 divided by 2, we don't have that listed yet. That's 5/2, 5 over 2. 10 divided by 2, 5. We've already got that listed, so we don't write it again. Right? Then we divide by 4. 1 divided by 4, we definitely don't have that listed yet. And then 2 divided by 4 is 1/2. We've already got that listed, so we don't have to do it again. 5 divided by 4, we don't have that listed. 10 divided by 4? 5 over 2. We've already got that listed. So this list is a little longer. We've got 1, 2, 3, 4, 5, 6, 7, 8, 16 possible rational zeros for that one. Okay? Making that list is important because we're going to look at the graph of the polynomial to help us figure out which ones to use. If we don't know what possible places its zeros are at, then we're going to have trouble picking the ones that are not at really good numbers. Okay, so these fractions, the rational zero theorem is important because it's going to help us know which ones to even try with our synthetic division, or what we should be getting for the zeros of the polynomial. Okay, so making that list is something I'm going to ask you to do for these problems. Okay, so be able to make that list. Factors of the constant divided by factors of the leading coefficient. Got to have it in what order before we can even do that? Descending order, just like we've been doing. Nothing new about that. Now, this will relate this back to what we did right before break. Okay, so start with example C. We want to do what the whole thing is about. Find all the zeros. And when I say all the zeros, I mean if we got a complex ones, we're going to find those as well. So all that's still involved. It's the same as what we've been doing. The only difference is we're not given one at the beginning. We've got to come up with it on our own. I'm going to show you how to come up with that. Okay, so let's start with this function. F of x is equal to x cubed minus 8x squared plus 11x plus 20. So we're going to start off before we do anything else and get our P over Q list. Okay. What's the factors that go on top? Factors of 20. What factors go on the bottom? Factors of 1. So we know if we divide all those factors of 20 by 1, it's not going to change them, right? We're not going to get fractions out of that, which is nice. So we know when we make our P over Q list, it's just going to be the factors of 20 because we're dividing them all by 1 because that's the only factor that's on the bottom. So what are the factors of 20? 1 and 20, 2 and 10, 4 and 5. Those are my possible rational zeros, 12 numbers that it could be, all right? So what I want to do is take that polynomial and do a synthetic division with it, but we don't know what number to put on the shelf. Before break, I gave you a number to put on the shelf. Here, you've got a smaller list of numbers. Instead of just one that you know works, you've got a list of 12 numbers that could work. Okay? When I was in high school, this is what I had to do. Yes. And pick one. If it worked, great, use it. If it didn't work, pick another one. Oh. Yeah. Because you guys have some technology in your hands, the graphing calculator, that can speed that up a little bit. We didn't have that. There were Miss Campbell had about 10 TI-82s back then, so not everybody had one, and I don't think Walmart even carried them. I never even looked for them anyway. But so we had to do it all without a calculator. You guys get the joy of using a calculator. So I'm going to set up my synthetic first, and then we'll figure out what to put on the shelf. So to figure out what you put on the shelf, you want to graph that polynomial. Okay? So we're going to hit y equals. I'm going to clear out some stuff that I've got in there. I'm going to type in that polynomial, x to the third power minus 8x squared plus 11x plus 20. Make sure you type that in correctly. Yes, ma'am. Y equals, top left button, right underneath the screen there. Clear out anything else you've got going on there. If you happen to have one of these things darkened in up there, you need to get rid of that.
So is there any like polynomial-based operations where you might take the list of zeros and might like add them up and then divide them by the number of them, kind of like median style?
You could, but it wouldn't do you much good. There are some rules about the actual zeros of a polynomial, and that if you take the constant divided by the leading coefficient, then that is equal to the sum of all of the actual zeros of the polynomial. Product of all the zeros of the actual polynomial, but it's but there aren't any that say take the possible ones and add them up and find that. There's nothing to do. No, there's nothing. There's no theorems or rules about that particular thing. All right, so got that polynomial in there. I'm going to hit graph, which is the top right button underneath your screen. And if yours doesn't look like that, hit zoom 6. So your screen will be the same as mine. Anybody have trouble getting that graph up there? Okay. Now, where are zeros of a polynomial at? What's another name for zeros? Intercepts. What intercepts? X-intercepts. So that means where that polynomial does what? Crosses or touches the x-axis. Okay? This one crosses it in how many places? 3. One on the left side of the x-axis right there. What number do you think that is? -1. Is that in our list? Okay. What number is this? +4. Is that in our list? +5. Is that in our list? Amazing. Okay. Now here's the thing. Not every one of them that's in our list is a 0. We had 12 numbers. There's only 3 of them that work. There are polynomials. It's not a maybe. There are polynomials that have only one rational 0, and the others are irrational or complex. Okay. So what we want to do is take one of these that works. Either take -1, +4, or +5, and use it as the shelf number for synthetic division. It doesn't matter which one you pick. Okay, I'm gonna pick an easy one that doesn't have a negative sign on it because that's easier. Negatives tend to mess us up because you mess up the sign when you multiply. So I'm gonna pick +4 to put on the shelf. Okay. So I'm going to put a +4 up here and then run synthetic division through here. What should the remainder be? 0. Okay. If the remainder is 0, we know that we did it right. Okay. 1 times 4 is 4. That's -4. -16. -5. What do you know? The remainder is 0. That is beautiful. Now, so what that tells us is that we've got zeros and we've got factors. We have a 0 of 4. What's the factor that goes with 4 as a 0? It's x -4. Remember, we kind of related those back the week before fall break. Okay, so the 0 of a 4 means a factor of x -4. Since we did synthetic division, we started with x cubed. What does this part turn into? X squared turns into a quadratic. So that means we get all the tools that go with quadratics for this part. Okay? So I'm going to work that as a quadratic. That's x squared minus 4x minus 5 equal to 0. What are my options? What's that little table over there? That's listing my zeros and the factors that go with it. Because I'm finding all of the zeros for this polynomial. Also going to try to find all the factors that go with it if I can. Okay. All right. So right now, this thing is factored as x -4 and x squared minus 4x. Remember, we did this the week before fall break. We factored it by using synthetic division, given a factor. You remember doing that? Okay, so wheels are starting to turn, cobwebs are starting to ball up and burn away. So we already know the zero that goes with that. We need to find the zeros that go with these. So we could do either factoring with the X method, because it's quadratic, or we could do what? Quadratic formula. That will work as well. I know that this will factor because I remember -5 and -4, that -5 times +1 works. So I'm going to use factoring. And then my factors would be x minus 5 and x plus 1. This is the factored form of that polynomial. Remember, we did that before fall break. The zeros zero of 5 has x minus 5. 0 of a -1 has x plus 1 as a factor. We found all the zeros. We also found all the factors out of that, because zeros and factors go together. All the instructions really ask for the zeros. Now, -1, did it cross the x-axis at -1? Yes, it did. Did it cross at 5? Yes, it did. Did it cross at 4? Yes, it did. Okay, so we found the zeros of that one. What is the highest exponent in the original problem? X to the third. How many answers did we find? 3. You should always find the same number of answers as your highest exponent in the problem. Okay. The beauty of mathematics is that nothing is coincidental. It all matters. Okay, it all comes together, making things happen. Let's look at another one. F of x is equal to x to the third power minus 4x squared minus 15x plus 18. Again, this is an easy one for P over Q, because we have a 1 in the leading coefficient spot. That makes things easy when that happens. Okay. So what are our factors of 18? 1, 2, 3, 6, 9, 18. Okay. Now, which ones of those work in synthetic division? How do I find that out? Graph the polynomial. X cubed minus 4x squared minus 15x plus 18. Be careful when you're typing in that polynomial. What you type it in correctly. You miss a sign or a number there, it's a completely different problem. And where it crosses the x-axis is not likely to be the same. Okay? So what are some possible numbers to put on the shelf? -3, 1, and +6. So +1, +6, or -3. Are those in my list? Yes, it should be. Okay. All right. Those are all good numbers. Here's another trick to know if one works or not, because sometimes we're going to, as we kind of move forward here, we're going to see some places it crosses the x-axis, but it's not going to be right on a number. If you hit the trace button, which is right next to graph, trace, and then type in the number you want to try. So I want to try -3. I'm going to hit -3 and then enter. Notice what the y value is. 0. That means, yes, that is where it's crossing the x-axis. If I tried 1, yes, the y value is 0. If I tried 6, the y value is 0. That proves to me, hey, Those work. So I'm going to use one of those in synthetic division. Okay, so I'm going to do synthetic division. Which one do y'all want to use? What's the easiest one? Positive one's the easiest one, right? Because everybody can multiply by 1. Okay. And it should be no surprise that you get 0 as the remainder. Okay. So 0 of 1 has a factor of x minus 1, right? Will that factor multiply be negative 18, add to be negative 3? 6, negative 6 and positive 3. So that'd be x minus 6, x plus 3. X minus 6 equals 0 gives me x equals 6. X plus 3 equals 0 gives me x equals negative 3. Shouldn't be a surprise. We saw those on the graph, right? We found the zeros. We found the factors. The factored form of that polynomial, if I ask you for that, because that's something we've talked about before, kind of trying to put it all together here. There's the factored form. Here are the zeros and the factors that go with them. So far, the ones we've seen, it crossed the x-axis at 3 nice, distinct places that were in our list. That's not always going to be the case. Be too easy if that's what's happening. Be too convenient. Be too perfect. Math, we like to try to make things perfect, but it doesn't always work that way. Most of the things you deal with, and when you try to relate real-world things to math, it doesn't work out real perfect. So let's look at one that doesn't work out quite as perfect. That's all of it. All right. Let's look at this one. G of x, 9x to the 4th plus 3x to the 3rd minus 30x squared plus 6x plus 12. We got a 4th degree polynomial here. 4, highest exponent's 4. So that means we should find how many answers? 4. That doesn't necessarily mean we're going to have 4 factors, but it means we're going to have 4 answers. Okay? So here's what we're going to have to do. Because we have a degree of 4, we can't just do synthetic one time, most likely, and be able to factor after that. Okay? We're going to have to do it a little bit more. Okay? But the process is very much the same. We're still going to make our P over Q list. This one's a little more difficult to make because we have factors of 12 and factors of 9. You could do it before. What would be the GCF of that? 3. So if you factored out a 3, that'd give us 3x to the 4th plus x cubed minus 10x squared plus 2x plus 4, which would then make your P over Q I did that backwards. I said P over Q and wrote P and Q in that order. 3 and 4 instead of 12 and 9. Does 4 have fewer factors than 12 does? Yes. So that's going to make that list smaller. So there's a case where pulling that GCF out at the beginning can make your list easier to make. Okay. So what are the factors of 4? 1, 2, and 4. That's much shorter than 12. Because 12, you got 1, 2, 3, 4, 6, and 12. So it shortened it up quite a bit. Factors of 3, 1 and 3. Okay. So our P over Q list, 1, 2, and 4. That's dividing them all by 1. Then divide them all by 3. 1/3, 2/3, 4/3. So we've narrowed that down from every number possible in the world to these 12 numbers. Positive and -1, positive and -2, positive and -4, and plus minus all those fractions there. Okay. So I'm hoping that one of these integers works when I graph this. If it doesn't, that's okay. We got some fractions that we could try. So we're going to try that first. So I'm gonna graph the original problem. 9x to the 4th power plus 3x to the 3rd power. Oops. And then minus 30x squared plus 6x plus 12. All right, got some stuff happening there. Where is it crossing the x-axis? Here's a spot right here. What number does that look like it might be? -2. Let's check it to see if it is. So I hit trace, -2, and hit enter. Is that going to work in synthetic division? Yes. What number could this possibly be? It looks about like maybe -1/2, but is -1/2 in our list? No, then it can't be -1/2. Only really, what's the only possibilities that it could be out of our list? -1/3 or -2/3, right? If I try those, -1/3, it's definitely not -1/3. What about -2/3? Definitely not -2/3. That's a different one. It's not in our list. That means it's probably coming from maybe quadratic formula, or it's an irrational zero, meaning it's got a square root still in it. Okay. What about over here? Looks like maybe right there it's crossing at 1, maybe. So I'm going to try 1. Hey, yeah, 1 works. So far we know that -2 is going to work or +1 is going to work. It's also crossing the x-axis just to the right of that over here, which in our list, the only thing that could be would be +4/3. So I could hit trace 4/3 and see if that works. It doesn't. Okay, so none of the fractions that I created in my list give us a 0 for y. So we know that they're not going to work. But I've got a couple of other numbers that will. So I'm going to set up my synthetic. And I'm going to go back to the original problem, the 9x to the 4th, and do my synthetic from there. So I'm going to use +1 first because that's the easier one. Make sure that you've got a representative from every power, starting with x to the 4th, 3rd, squared, 1st, 0. Some of them might have a missing piece. Remember, we've got to put a 0 in that place. And there I get a 0 as the remainder. So we know that 1 is a 0. Now, I did synthetic division. We started with x to the 4th power. What does that mean this is? X to the 3rd power. Do I have any tools for things that are x to the 3rd power? No, I've got a lot of tools for things that are x squared. We got, quadratic formula, factoring, all that fun stuff. Solving by square roots even comes up if you're doing x squares. We don't have a lot of tools for x cubes. So that means I need to do synthetic another time. The good thing is, do I have another zero that I know about? Which one? -2. So I'm going to do synthetic on this polynomial with -2. So these become my coefficients, and I put a -2 on the shelf. Okay? I'm doing synthetic until I get down to a quadratic. That's what you want to be doing when you're solving these polynomials out all the way. So you want to start doing synthetic until you get down to something that has x squared. Okay? Once you get to x squared, that opens up quadratic formula and all those things that we have from there. Okay? So run the -2 through there. So that's 9, -18, that's just -6, that's 12, that's -6, and that is 12, and there's a remainder of 0. So I have -2, which has a factor of x plus 2. We know that this is 9x squared minus 6x minus 6. That's how we factored it so far. Now, back at the beginning, Shaw told us that there was a GCF. Is that GCF still in here? Yeah, it's still there. So we can pull it out as well. That'll make things easier when I solve that. So I'll pull that 3 out. That's going to give us 3x squared minus 2x minus 2. Now, I've already got the zeros for these two. We did those with synthetic division. That's where they came from. And so I need to get the zeros for this quadratic. Will that factor? -6 and add to be -2. Well, my options are -6 and 1 or -3 and 2. Either of those work. It won't factor. So that means I have to solve it which way? Quadratic formula is the only way I can solve that one. So I'm setting up my quadratic formula. -b plus or minus the square root of b squared minus 4 times a times c. All of that divided by 2 times a. So that quadratic formula that we did about a month ago, still got to be able to do it. Okay. So b squared is 4 minus, or no, that'll be end up being plus because 12 times 2 is 24. 4 plus, excuse me, 24. Excuse me, it's 28. So we got 28 underneath the radical over 6. Let's break down the 28. 4 and 7. Pair of 2's. So 2 plus or minus 2 radical 7 over 6. What do I know about all three of these numbers that I've highlighted? They're all even, right? So that means they all can be divided by what? 2. So I'm going to divide them all by 2. So that'll be 1 plus or minus 1 radical 7 over 3. So our zeros, 1 plus or minus radical 7 over 3. That's 2x. We have +1, -2, that's 2 of them. 1 plus radical 7 over 3, that's the third one. 1 minus radical 7 over 3, that's the fourth one. What was the highest exponent on x in our original problem? 4. It goes together. Okay. So we have, now, this value right here are those in-between ones that we tried the fractions for on the graph. 1 plus square root of 7 divided by 3 is where that thing crosses. I'm going to hit trace 1, and I'm going to put parentheses 1 plus. I'm just going to show you this. Square root of 7, close the parentheses, divided by 3. That's where it's crossing right there. Notice the y equals 0. Okay. It'll do that as long as it's a real solution and not a complex one. You can't check complex ones here. They're not going to cross the x-axis anyway. Okay. But here we have that when if I did the 1 minus, it would get me this one right here. It's what that place where it crosses the x-axis are. Okay. All right. Let's do another. F of x is equal to x to the 4th power minus 22x minus 75. Fun one. Looks like it's short. That's x squared in the middle, sorry. X to the 4th minus 22x squared minus 75. X to the 4th power minus 22x squared minus 75. Okay. We're finding all the zeros of that polynomial. The first thing we're going to do is make our P over Q list. Okay. Factors of 75. 1 and 75. What else goes into 75? What's the next smallest number? 3 and 25. 3 and 25. 5 and 15. So those are the factors of 75. The factors of Q. What's Q? 1. So that means we're going to just divide all those by 1. So it's not going to change our list any or make it any longer. So I'm just going to stop there, and that's my list. Because the leading coefficient is 1, I can do that. Okay, so my list has been narrowed down to 12 numbers. All right. How do I set up my synthetic here? One, 0, negative 22, 0, negative 75. Be careful of that. You're doing this. If you leave those zeros out, it can really cause some problems. Won't always cause problems, but it does enough that if you miss one of them, it's usually that's the reason. All right. Now, what's the next thing that I should do? Graph it on the calculator, right? Graph that original polynomial on the calculator and see where it's crossing the x-axis and see if we can see that happening. So go to y equals, clear that out. X raised to the 4th power minus 22x squared minus 75. I'm hitting graph. How many places do I see it crossing the x-axis? 2. But it's x to the 4th power. How many places should it cross? We think 4. That doesn't necessarily mean it will cross. The degree is 4. The highest exponent is 4. That doesn't mean it will cross the x-axis at 4 places. That means we'll have 4 zeros. It's crossing twice here. That means, okay, well, I've got 2 zeros that I know of. I can see them happening right there. What are those numbers? 5 and negative 5. Right? You know it's crossing there. If I do synthetic with those, that'll get me down to a what? Start with x to the 4th power, do synthetic once, it gets it down to x cubed. Do synthetic a second time, it gets it down to x squared. That will let us find the others. Okay, so that's what we're going to do here. Same process. I'm going to start with the positive 5, just because it's 5. Positive 5 is easier than negative 5. Doesn't matter. You could start with the negative 5 and you're going to end up the same place. Okay. It does not matter which 0 you start with. Keep that in mind. because you may do the problem differently than your neighbor, but you should end up at the same place. Okay. I'm going to do synthetic again. But what's going to go on the shelf this time? -5, the one I didn't use yet. Okay, we saw it crossing the x-axis at 5 and -5. So I use the +5. Now I'm going to use -5. If you happen to make a mistake and try to use 5 again, it would not work. Okay? So as long as you're doing your synthetic correctly, you can't screw it up. Okay? Put 1 in there. There's that remainder of 0. So that gets us, so far, a factored form of that. X squared plus 3 is the quadratic that's left. How can we solve that? Set it equal to 0. And we got 2 options on this one. We could do quadratic formula. B is 0, A is 1, C is 3. And you can work it out that way. Or you could just get x squared by itself and then do what? Take the square root. That's what I'm going to do. X squared is equal to -3. Take the square root, plus or minus in front of that one. What's the square root of -3? It'd be I radical 3, right? So we get +5, -5, positive I radical 3, negative I radical 3. How many is that? 4. What's the highest exponent? 4. 4 zeros. Highest exponent in the problem was 4. That goes together. Okay. It's called the degree of the polynomial. It should match the number of zeros we've got. Okay. It's going to take a little bit of practice. What I've gotten you here is a kind of a starter pack. Get you going. The first 5, you're just making the list. The next 15, you're actually doing. The answers are on here, so you can check to make sure you got them right. Okay, this is just so. Khan Academy, I don't have that prepared for you yet, but hopefully, since we're doing everything now, we'll be able to go back to doing some Khan Academy on Wednesday. But this will get you started. Yeah. Got 15 minutes or so left. Definitely get started on this. At least do 1 or 2 problems in 15 minutes there to get you going, so that you're not sitting there not knowing what to do tomorrow when you're off and I'm here. If your parents are coming to parent-teacher conference tomorrow and they need to speak with me, tell them to avoid the 2 o'clock to 3 o'clock time slot. I've got to go for my parent-teacher conference for my kids. And our time frame for that is at 2 o'clock. So I won't be in the building at that time. I picked that time from my time slot because that's usually the deadest time here. Nobody's usually here for that time. So if your parents are coming to the parent-teacher conference, talk to me. Tell them don't come at 2 o'clock. from 2 o'clock to 3 o'clock. I should be back before 3. Hopefully it doesn't take long. But you never know. Our kids could be trouble. Okay, let's see if we can fix you up.
Okay, when I do that, like, this is like